Hello friends, I am Vinod D'Souza, Associate Professor, Department of Civil Engineering, AJ Institute of Engineering and Technology, Mangalore. In the previous discussion, we started the topic called as chemical modification, and in that chemical modification, we have discussed about the first topic, that is called as mechanical modification. Mechanical modification is nothing but here we are not going to add or remove any external chemicals to the soil. Instead, we are mixing the coarse grained soil with the fine grained soils properly so that the voids contents or voids ratio will be minimum, and because of that density will increase, and in turn it will improve the strength of the soil. So in case of mechanical modification, we are altering the soil structure or changing the gradation of the soil, and that's how we are improving the strength of the soil. The second part is called as chemical modification, and in this topic we are learning about various chemicals, how they can be added to the soil, and how the properties are going to change, or what chemical reaction is going to occur when we add these chemicals to the soil, and that is termed as chemical modification. So in that we can use various chemicals to the soil, like we can add cement, we can add bituminous, we can add lime, we can add fly ash, we can add some salt materials, lignin. So variety of materials can be added, can be tested to improve the properties of the soil. So still the research is going on by adding two or three different materials with a combination. So out of which cement is the most widely used chemical for the soil, because it is available in plenty, and we already know the properties of the cement because we are using its cement for various constructions, and it acts like a binding agent. Since we know the property of the cement, so it is easy to use in soil so that we can improve the strength of the soil. Let us begin with the introduction. Already we know that stabilization is the improvement of a soil or pavement material, usually through the addition of a binder or additive. Cement again is a binder which is used either in concrete or masonry to bind the particles together. So here also, when we add the cement to the soil, it will bind the various particles of the soils together. That's how it will improve the cohesion of the soil. A wider range of soils can be improved for bulk fill applications and for construction purposes. The most common method of stabilization involves the incorporation of small quantity of binders such as cements to the aggregates. As a stabilizing material, cement is well researched, well understood, and its properties are clearly defined. That's why for us also, whenever we are thinking of improving the strength of the soil, first chemical comes to mind is the cement. Generally or normally for all construction purposes we are using this cement, available in plenty quantities. That's why we can add this cement to the soil and we can see what properties are going to change or how it will improve the strength of the soil. Cement stabilization of soil is done by mixing the pulverized soil and Portland cement along with water and compacting the mix to attain the strong material. So we need to take the cement with prescribed quantities, then we have to add required amount of water, and then should be mixed with the soil properly, and then finally it has to be compacted so that a strong material is obtained which can be used either for pavements or for the building construction. The material obtained by mixing soil and cement is known as soil cement. As we know that the material which is obtained by mixing cement, coarse aggregates and fine aggregates, it is called as concrete. So here the term is given as soil cement because for soil we are mixing the cement. Since 1915, more than 1 lakh miles of equivalent 7.5 meter wide pavement bases has been constructed from cement stabilized roads. Okay. Still we are learning now about the cement, but this technique was used from much earlier days, from 1915 onwards. Cement stabilized materials generally fall into two classes. One is called as soil cement, second one is called as cement modified soils. Soil cement is a mixture of pulverized soil material and cement. When you take up the pulverized soil and it is mixed with the cement, then that term called as soil cement has existed. Whereas cement modified soil is a soil treated with small proportion of soil cement. The difference between two is soil cement, where soil is mixed with cement and then it is brought to the site, it is spreaded and it is compacted. Whereas cement modified soils are soils which are mixed with the required amount of cement at the site itself, and they are termed as cement modified soils. For smaller works, we can go for soil cement because we can take the required amount of soil, we can take the required amount of cement, it can be mixed thoroughly and then it can be brought in place at the required site. Whereas for longer constructions, larger construction or longer roads, it may not be feasible to take out the soil, mix with the cement and brought to the site. So in that cases, whatever soil available at the site, it will be retained, an amount of cement is taken, it is mixed with that soil and then it is compacted. That is termed as soil cement. Next thing is factors affecting soil cement stabilization. Okay. What are the factors which we have to consider while doing this soil cement stabilization? So first thing comes to your mind is the type of soil, because normally the properties of the soil varies from places to places. Whatever soil we are going to get at one place, it may not be the same what we are going to get at some other places. You can say that a property will be changing from a smaller distance to a larger distance. Similarly, the property will change from depths. Whatever depth available at the top level, whatever properties available at the top level will not be same as that what we are going to get from the deeper levels. So we have to see what is the type of soil available at the required site, and based on the type of soil we have to decide how much amount of soil can be added to the cement can be added to the soil. We have to see whether the soil is fine grained, whether the soil is coarse grained, or is it a mixture of fine and coarse grained soils. Second factor what we need to consider is called as quantity of cement. Still we are under research process, even it is not possible to find out the exact quantity of cement which gives us the maximum strength, but various theories says that an amount of 10 to 15% can be added, again depending on the type of soil. Okay. And this quantity has to be taken, it has to be spread properly to the soil so that it mixes properly with the soil along with the water, and then it should be compact. Third thing or third factor to be considered is called as quantity of water, because cement by itself will not give us the required strength. It has to be mixed with certain quantity of water so that the hydration process has to be generated, and then only it will give us the required strength. So now we have to decide how much water is required to mix with the cement, and that water, it should be of optimum quantity. If the water quantity is less, the hydration required hydration process will not be generated and it will not mix thoroughly with the soil. In the meantime, if the water added will be of more quantity, then there are chances that cement particles will flow along with the water and it will not be a proper mixture. That's why it is essential to know that we have to get the required amount of cement. Next factor regarding mixing, compaction and curing. Whatever amount of cement we have taken, we have to see that the cement thoroughly mixes with all the particles of the cement. Maybe the quantity of cement what we are taking will be less compared to the quantity of soil. It may be only 10 to 15%, but we have to see that this 10 to 15% quantity of cement thoroughly mixes with all the particles and it is able to bind all the particles together. Once it is mixed, it has to be compacted thoroughly by using various mechanical means, maybe smooth wheel rollers, maybe compactors, maybe vibrators. We have to compact it properly so that we'll get the required strength, and later it should be allowed for curing. We cannot use immediately after the compaction for the vehicles. We have to wait till then the soil cement gets properly cured. Sometimes cement itself will not give us the required strength. At that time, it is better to add certain admixture to the cement so that we can get the required strength. Again, all this depends on the type of soil which is available in the site. Some type of soil will not react with the admixture what we are using. A thorough investigation should be done, and then only we have to decide what admixture should be added and what should be the quantity of the admixtures. So the advantages of adding cement to the soil is, as I've told you in the beginning, cement is widely available because it's a common material used for construction. Every places the cement is available. Variety of brand names are available, so it is easy to get cement. That's why commonly used material for stabilization is cement itself. If we are going for certain chemicals, then we have to bring them from faraway places. The costs will also be mostly costly. That's why first thing comes to mind is only cement. Its cost is relatively low compared to other chemicals. It is highly durable. Once we mix the cement with the soil, properly compacted and cured, the durability of the soil will be higher. It will sustain for longer durations. There are chances that some chemicals, once you add it with the soil, during rainy seasons they will wash out along with the water. That's why it will not give us the required strength. But cement, it is not like that. Once the hydration process is generated, it will be a permanent structure. It will bind the particles together so that it doesn't allow the particles to go away from each other. Soil cement is quite weather resistant and strong. Similar one, okay, for any weathers, maybe extreme heat conditions or maybe extreme colder conditions, heavy rainfall, the strength will not be reduced. Once it is properly binded, it is not possible to remove it, and also it is strong. Soil cement reduces the swelling characteristics. When we feel the swelling and shrinkage characteristics, if the voids are present in the soil and if the water enters through these voids, definitely the soil is going to swell. But in case of cement binded with soil, the particles will restrict each other. There is no chance for the voids to develop, hence there is less chance the water will enter into the soil, and when the water will not enter the soil, definitely there won't be any possibility of swelling and shrinkage of the soils. As we have seen the advantages, there are Also, some disadvantages will be there, and those disadvantages are cracks may form in soil cement. If the soil cement is not properly cured for extreme heat conditions, definitely it's going to crack. And if it cracks, there are chances that water may penetrate inside the soil. It is harmful for the environment. We know that cement usage is harmful for the environment, and we are reducing the quantity of cement for the constructions. We are adding certain waste products from the industries like fly ash, GGBS, so that we can reduce the content of cement. So we know that it's harmful for the environment, and it requires extra labor. We need extra labor to see that the cement is thoroughly mixed with soil, thoroughly compacted, and for curing. That's how the cost will increase. The diagram shows the process of mixing cement with the soil. We can see here the direction of movement towards the right direction, and this portion shows the untreated soil, whereas here backside it shows the treated soil. See, before mixing, you can see spreading cement ahead of the machine. Okay, you have to spread the cement evenly on the surface of the ground so that it acquires all the position. Then there is a machinery, and to the machinery a microscope or controlled pump for spraying water is fixed. Okay, and it will spray the water evenly on all the surfaces, and that's how mixing is going to take place. This process is called as mixing and mixing drum, and once it is mixed, the treated material looks like this. Backside you can see this is the process of mixing the cement with the soil. Once the mixing is done, then the compaction is going to start. Some more figures we can see at the end of this discussion. Let us see each and every factors thoroughly. As you see, first thing you have to see about the type of soil. What type of soil available in the site? Okay, and that is called as nature of soil. As far as talking about the cement stabilization, all inorganic soils which can be pulverized can be stabilized using cement. Okay, whatever soil available, if we are able to mix them thoroughly with the cement, definitely they can be stabilized using cement. Okay, soil with higher specific surface requires more cement for stabilization. Some soils which are having higher specific surface, okay, like coarse grained soils or other things, where the quantity of cement will be slightly more, whereas for normal soils the quantity will be somewhat lesser. Presence of clay in soil causes problems in pulverization, mixing and compacting the mixture. If clay content is more in the soil, there will be a problem of pulverizations. Okay, once we mix, it will not be a proper mixer, and once it is not mixing, then it's difficult for compacting the mixtures. Exchangeable ions in a small influence the response of soil treatment. Calcium is the most desirable ion for the use of cement stabilization. Lime or calcium chloride is sometimes added for clays being stabilized in water. Okay. Apart from organic matter, the chemical composition of the soil is of importance only if appreciable quantities of deleterious salts such as sulfates are present. The following table shows us what are the limits that can be used for the soil. If you see the table, it indicates particle size distribution limits and plasticity charts. And it says that if the soil is passing through 4.6 mm IS sieve, its plasticity should be greater than 60%. Passing 4.6 maximum size 76 mm, the plasticity limit should be less than 40%. Passing through number 40 IS sieve, the plasticity should be greater than 15%. Passing 75 microns IS sieve, the plasticity should be less than 50%, and plasticity index of the soil should be less than 18%. In general, the best results are obtained with well-graded soils having less than 60% of its particles finer than 0.075 trim and a plasticity index less than 20%. This is the general criteria. The soil should be of well-graded soil, should be have less than 60% of its particle finer than 75 microns, and plasticity index should be less than 20%. So in this case, we can get better results when we mix soil with this cement. The next thing what we have to discuss is the amount of cement. Again, initially you have seen that if the surface area is large, we require more amount of cement. The same thing it says that soil cement has been made with cement content varying from 6 to 20% for satisfactory stabilization. Various researchers has given various quantity of cement by its weight, also by using different types of soil, and the following table shows that for gravels whose size will be larger, the amount of cement is required is 5 to 10% by weight, and for sandy soils the amount of cement will be 7 to 12% by its weight. For silty soils, the amount of cement which will be a little more, which is 12 to 15% by weight, and for clay soils, the content of cement should be 12 to 20% by its weight. When the cement is hydrating satisfactorily in a machine, an increase in strength is obtained with an increasing water content. The cement content required is usually determined by measuring the compressive strength of specimens made with different proportions of cement. It can be observed that a given increase in cement content with more clay soils produces a smaller increase in compressive strength than a sandy soils. Next thing is about the mixing, which will be a very important topic in case of cement soil stabilization. If the mixing is not done properly, the cement will not be spreaded on all the particles and the results obtained will be of lesser strength. More uniform soil cement water mixture provides strong and durable soil cement. If we able to spread the cement, and if you see that the cement spreads to all the particles, then definitely we are going to get more stronger soil, also a durable soil. In the same time, increase in continued mixing causes a decrease in the degree of mixing and may lead to segregation of components. Whenever we do the mixing, it has to be in a proper manner and it has to be for a specified time. If we do the mixing continuously, there are chances that segregation of cement and soil particles may take place, which in turn reduces the strength of the soil. Mixing should be only up to the optimal level. Beyond that level, we have to stop the mixing and we have to wait for the curing and compaction. Also, it says that mixing after cement hydration will have deleterious effects. Once the soil has hydrated, it starts gaining the strength, and later if we continue the mixing, it will have the deleterious effects like cracks or segregation. That's why we have to see that what is the optimum level, and only up to the optimum level we have to continue the mixing. These figures show how the soil is mixed with the cement. Initially, it is sprayed, it is mixed with various machineries, and finally, we can see a finished surface how it looks. Moisture content that indicates the amount of water which has to be added to the soil cement. The moisture content plays two roles in soil cement. One is it influences the compaction characteristics as with natural soil, and second, it furnishes water for cement hydration. We know that for compaction of soil, moisture content plays an important role, and we know that soil will give us the maximum strength for its optimum moisture content. So initially it has to be decided what will be the optimum moisture content of that particular soil, and only up to that amount water has to be added. It should not be more than that. And this water, whatever added, it also furnishes the hydration of the cement. Okay? For hydration of cement, we require a certain amount of water. That's why water plays these two roles. The effect of moisture content on the quality of soil cement largely arises from its influence on the compaction. The best moisture content for compaction is governed by the soil type and method of compaction. Various soil types are having various amount of moisture contents, and they require various types of compactions. Like for coarse grained soils, we have to roll it either doing vibrations or by using smooth wheel rollers. Similarly, for fine grained soils or clay soils, we require sheep foot rollers or pressings. And if we adopt the proper methods, definitely we can get the required strength of the soils. Compaction conditions. Again, to compact the soil, adequate compaction is essentially, and the graph shows the relationship between dry density and compressive strength of 10 centimeter soil cement cubes. You can see that as the dry density of the soil increases, its compressive strength keeps on increases. That's why it is essential to compact the soil in dry conditions. Curing, which will be the last step in the soil cement stabilization. As with concrete, the compressive strength of the soil cement increases with age. That's why essential curing is required. Okay, so that the hydration process gets completed fully. Soil cement cures rapidly with increase in temperature, although it will harden at all temperatures. If the temperature is high, the curing will be done quickly, it cures quickly, and it will get the required strength quickly. Sometimes cement itself cannot give us the required strength. At that time, we need to add certain admixtures to the cement. Use of some chemicals along with cement have important advantages, such as reducing the additive quantity needed to perform the given job, thus simplifying the handling and mixture, and also reducing the total stabilizer cost. By adding the admixtures, we can reduce the quantity of cement to a certain extent, which will in turn reduces the cost. Also, we can increase the setting time of the cement. Okay, so that we'll get the enough time for the mixing of the cement and soil. The construction procedure for soil cement stabilization is as follows. First step always is the shaping of soil to be treated. We have to mark what will be the boundary of soil cement stabilization is required. If it is single lane, it will be around 3 to 3.5 meter. If it is double line road, 7 to 7.5 meter. A certain margin of 1 meter extra has to be kept so that later we can trim it to the required width. That's why first step of construction is always shaping the soil to be treated. Once the treating is done, second step is pulverizing the soil. Whatever soil, existing soil, we have to pulverize it, we have to mix it, we have to loosen it, and we have to mix it thoroughly so that later once the cement is added, it will be mixed thoroughly with the soil. That step is called as pulverization. So various machineries are available to pulverize the soil. Okay, by using that we have to pulverize, we have to loosen the soil. And third step, adding water and cement. We have to add we have to spread the cement thoroughly, evenly on the surface so that it spreads on all the particles, and then along with that we have to sprinkle the water so that proper hydration process takes place. Once it is done, we have to mix it thoroughly. Once the mixing will be done up to optimum level, then we have to compact the soils by using various compactors. Then next step will be the finishing, where we have to trim the sides to the required width, and later we have to allow it for curing of minimum 1 week. Again, it depends on the temperature. If the temperature is high, 3 to 4 days curing is sufficient, or otherwise normally we have to leave it for 1 week so that it gets cured properly and it acquires the required strength. So as a conclusion, we can say that cement has been found to be effective in stabilizing a wide variety of soils. The addition of cement and the reduction of porosity prompted an increase in unconfined compressive strength of the soil. Water content does not have a major influence in the unconfined compressive strength of cement stabilized soils. The cement stabilized soils will maintain significant strength even if it becomes saturated. So one of the best chemical you can be used is cement stabilization of soils. Thank you, friends.